So this will be the last chapter we will be covering. And so for today, we then have chapter 13, which deals with statistics. All right. So let's start out with things you probably heard of, which being these three terms, being the mean, the median, and the mode. Well, the mean, that just refers to the average. The median is the number that is in the middle when the numbers are in numerical order. Numerical order. So we rewrite their list in from low to high. And then the mode is the number that occurs the most. So mean, median, and mode. So let's look at that in terms of a group of numbers. So if I have this group, 4, 8, 21, 5, 9, 11, 25, 9, 4, 17, 30, 9, and 18. So there's my group. And so the first thing I want to do is find my mean. So really to find the mean, we're going to have the total divided by the number of items. So we would add all those numbers up, and when we do that, we would find out this comes out to be 170. There are 13 numbers in my list. We divide that out, and we basically come out to be 13. We're going to round that to the nearest whole number. So that is my mean. Okay? The next thing then we want to find is our median. Well, to do the median, we need to take our list and we need to rewrite them in numerical order. And so I'm going to rewrite the list. So 4, 4, 5, 8, 9, 9, 9, 11, 17, 18, 21, 25, and 30. Right? So when you rewrite the list, you want to make sure that, so here we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 numbers in the original list. So you want to make sure when you rewrite your list for your median, you also have 13 items. That way you make sure you didn't forget any numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and the numbers match. So the median then is the number that is physically in the middle of the group. And so for me, that number is this number right here. This is the number that is physically in the middle. Because there are 6 numbers to the left of it, and there are 6 numbers to the right of it. Right? So my median here is going to be 9. And then the next one then is the mode. And so the mode is the number that occurs the most. And for me, this list we got, well, 4 occurs twice, but 9 occurs 3 times. So 9 is the mode. Right? So mean, median, and mode. So a group of numbers does not necessarily have to have a mode. There may be no mode. There could also be more than one mode, depending on your set of numbers that you have. Okay. Well, the other kind of average is then in terms of a weighted mean. Okay. And a common example where you've seen this used comes in terms of your grade for the class. Is based on this idea. And so we had from our syllabus that the homework is 35% of your grade. The discussions were 15%. The exams are 30%. And then the projects are 20%. Right? So let's say that for a given student, their grade, so their average in terms of each of these categories. So for this student, they averaged a 92 on the homework. They did all the discussions, so they got 100 there. They had an 85 for the test, and then a 90 on the project. So we want to be able to calculate what is their final grade for the class going to be. So to do that, we're going to have, this is going to be 0.35 times 92 plus 0.15 times 100 plus 0.3 times the 85, and then 0.2 times the 90. And we put that all together, and you end up with a grade of 90.7. Right? So we have in terms of that. Right? Well, other ways of dealing with data and data sets is we can have in terms of what is called a frequency table. And so I put together a list of numbers. And so let me do this. Pull this in here. Oops. Hey. Back, all right, and I'm gonna copy this and copy and go back here. All right, and right. So these are a group of house prices I got off of Zillow for houses in Renton. All right, so these are house prices in Renton, again, off of the Zillow website. And I decided, well, I'm going to make a frequency table based on this data set. Right? So when we do a frequency table, we basically have to come up with what we're going to call bins. Right? And so to do my bins, I said, okay, let's make my bins based on the following. We're going to go from 470,000 at the high end to 240,000 at the low end. Right? And then I decided I want to do this in terms of 5 bins. And so that means that we're going to have 46,000 in terms of each bin. Right? Which means then the way this would work in terms of my bins, my first bin is going to be 240 to 286,000, and so on and so on, right? Right? And so let me pull that over here, and I have my table for this. And bring that over here. And so if I put this in here, this is the frequency table for that set of data. So I had 2 numbers that were in between 240 and 286,000. There were no home prices in the range of 287 to 332,000, and so on. So I got in terms of how many were in each of the groups, right? And then the other chart, the next one is the relative frequency. And the way we get that number, so for example, we had 2 houses out of 27. And that gave that 0.074 number, right? So that's how that number comes about, right? And if you add up all those relative frequencies, they should add up to 1, right? So we have, in terms of our frequency table, given this, right? The other thing which I didn't put in here, but let's put it in here, is you could also have a column that said cumulative frequency. And so here, this would be 2, 2, 5, 14, and then 27. So cumulative frequency basically column is basically just a running total of what we had. Right? And then the other thing we can do is, with this data set, is we could then also make a table to represent, or we made our table, we could also make a chart to represent our data. And so we could get this, right? So I have, in terms of this chart, that represents the house prices and rent-in. So I got it labeled, and it tells you how many houses were in each of those bins on my frequency table. Right? Right. So frequency tables are another way of representing a data set. Right. Other thing we can do with our numbers then is we can talk about the range and the standard deviation. So first off, the range. And the range is basically just going to be the high number minus the low number. Right? And so if I take that original list of numbers that we had, and let me rewrite them. And I'm going to rewrite them in numerical order. We said the numbers were 4, 4, 5, 8, 9, 9, 9, 11, 17, 18, 21, 25, and 30. So my range here is going to be the 30 minus the 4, and we get a range of 26. And then the other number we're going to look at here now is the standard deviation. Standard deviation basically tells you how dispersed the data is. And so we're going to go through the process here for this set of numbers, right? And so I'm going to rewrite my numbers out, right? And so we had 4, 4, 5, 8, 9, 9, 9, 11, 17, 18, 21, 25, and 30. All right. So I'm going to call these numbers my x values, okay? Now remember, from the previous page, we said that our mean, which will represent as x bar, we said I was going to round it to the nearest whole number, and I said that number was 13. Right? So the next thing we're going to find then is what is x minus x bar. Right? So we're going to do a little subtraction. So I do that set of numbers. I get minus 9, minus 9, minus 8, minus 5, minus 4, minus 4, minus 4, minus 2, 4, 5, 8, 12, and 17. So that's that set, all right? And now the next thing we need to calculate is going to be this. And this is going to be x minus x bar squared. So now we're going to just square all those numbers. And so this is going to give me 81, 81, 64, 25, 16, 16, 16, 4, 16, 25, 64, 144, and 280. No. Right? So we took all those and we squared them. And then what we want to do is we want to find this total. So we take all those numbers and we add them up. And I get for this one 841. So my standard deviation then is going to be the square root of 841 divided by the number of items that we had. In this case, that number was 13. And so this number comes out to be 8.04. So my standard deviation here then basically is 8. Right? So my standard deviation. And so depending on, so we divide by n if it is the population, right? And we divide by n minus 1 if it is a sample. Okay. So if my set of numbers represents all the numbers, then we would divide by n. If my set of numbers is only a sample of the entire population, then we would divide by n minus 1. Right? Okay. Other things we can find then is also the other term, which is called the variance. And the variance is just equal to the standard deviation squared. So in the case of my numbers, we said my standard deviation was 8.04. And if we square this number, we get 64.64. Right? So in terms of some of the symbols that are used, we have in terms of, this is for the standard deviation for population. And then sigma squared is the variance population. And then we have S if we're talking about the standard deviation for a sample. And then S squared if we're talking about the variation for a sample. Okay. And then the other symbols we use mu if we're talking about the mean for a population. And then X bar if we're talking about the mean for a sample. So in terms of some of the symbols you'll see, right? So other things you'll see then are, in terms of all this stuff, has to do with what is called a z-score. Which really tells you how many standard deviations of how many standard deviations you are away from the mean. And so you get in terms of the normal distribution and z-scores. So let's do a little bit on normal distributions before we get to how you calculate z-scores. So first, so in terms of my normal distribution, right? And what is then? So let me do this. So normal distribution. So this comes from out of the book. Every normal distribution has following. The graph is symmetrical about the vertical line through the mean. The mean, median, mode are equal. The y value of each point is a percent. Area under the curves are symmetric about the mean, and the total area under the curve is 1. So a normal distribution is a nice symmetrical curve. So it looks something like this. Not very symmetrical, but there we go. Okay. And we have that everything is lined up with the mean, the median, and the mode. So those things are true in regards to our normal distribution. And then in terms of our distribution, we have this basic rule dealing with our data set. And so let's put this also here. So for a normal distribution, so 68% of the data is within 1 standard deviation, 95% is within 2, and 99.7 is within 3 standard deviations of our values. So now let's talk about z-scores. Z-scores tell you then basically how far away you are from the mean. So a z-score. And so for population then, the way you calculate this, you have the z-score is going to equal the value minus mu over the standard deviation. Okay. So here x is the value, the number you're interested in. Again, mu is the mean and sigma is the standard deviation. And then if it was a sample, the z-score is again x, the number, minus x bar, which is the average for the sample, divided by s. Right? So how does this work then? So let's say here we have something like this. So here we got given that the class average on a test was 72 and had a standard deviation. Standard deviation was equal to 10. What is the z-score? Z-score. Try that again. So what is the z-score for someone who got a 90? And so my z-score for this person, z, is going to be 90 minus the 72 over 10. And so this is going to be 18 over 10. And we get a z-score of 1.8. So z-scores. So in terms of z-scores then, you can also look in terms of tables. There's tables for these things. And so let's pull up that. And so let's pull. Let's see. Let me see here. Can I copy this? Okay. So we have in terms of this chart. Let's see if I can make it bigger. Does it make it more readable or not? Yeah, not very readable. Let me do this. This is not very readable. Let me see if I try this again. No. Unfortunately, this table is not very readable to plug it into this diagram. So I may have to send it out to everybody because it's not copying very well here, but let's leave it there. But basically the way this works in terms of a z-score is it tells you how much area is to the left of your number. Right? So we just said in terms of my person who got a test score from above, we said the z-score for that person was a 1.8. And so if I look on this chart and say, okay, 1.8, I would find that that this corresponds to an area. So the area to the left of that value, and what it can find by reading my chart, that number comes out to be 0.9641, which means what that would mean for this person is they did better than 96.41% of the class, right? Is what that z-score corresponds to, right? Right? So they did a lot better compared to the rest of the class here, right? And again, I'll have to load this chart into Canvas for everybody can get a hold of it because it didn't copy very well into here. Right, but again, given a z-score, you could then, and then another question you get with a z-score is how much area is between z equal to negative 1.42 and z equal to 1.05, right? So negative z-score, basically what that means is you are to the left of the mean, median, and mode, and a positive z-score means you're to the right of the mean, median, and mode. So if I want to know what is the area in between, and I say, okay, well, we're going to first find my z of 1.05. And so I go to my chart, I find 1.05, and I get 0.8531 for here. And then if I do the z-score of negative 1.42, and I find that value, I get 0.778, 0.0778. And so now I could subtract 531 minus 0.0778, and we get this corresponds to 0.7753 would be the area in there, right? All right. All right. Other things we can calculate then in regards to our numbers is we could find in terms of percentile for a given data value. And so by the way, you get the percentile score. So you see a lot of this when you talk about standardized testing and you compare people. So the number of values less than X divided by the total number of values. Okay. And then multiply that by 100 and you get 8%. Okay. Right. Other things we can do with our numbers then is we can do quartiles and then box and whisker plots. So quartiles. So let's go back to my original set of numbers for 4. And again, the numbers written in numerical order. 9, 9, 11, 17, 18, 21, 25, and 30. Right? And let's put in our median, which we said was here. This was my median. Okay. And in terms of quartiles, this corresponds to Q2. Okay. So Q2 is the median, which in this case is 9. Right? So now we want to find Q1. And so for Q1, we take the numbers that are less than our median. So that's going to be the numbers 4, 4, 5, 8, 9, and 9. And again, now we want to find the median for this group. And so this time, it would actually be these two numbers are physically in the middle. And so here we would get 5 plus 8 over 2. And this gives me 6.5. So we have that Q1 equals 6.5. And then if we want to find Q3, we take the numbers that were to the right of our median. And so now we have the numbers 11, 17, 18, 21, 25, and 30. And again, we want to find the number in the middle. And so now it's going to be these two. So this is 18 plus 21 over 2. And this gives me 19.5. So let's write down what we now know. We know that Q1 is 6.5. we know Q2 is equal to 9, and we know that Q3 is equal to 19.5. So now we can come up with our box and whisker plot. And so we get something that's going to look like this. And so we get our box here. Okay. And the way things correspond here is this is Q1. This is Q2. This is Q3. So for me, my numbers here are going to be, this is 6.5, this is 9, this is 19.5. And then you get the whisker part of it. And so we have one here. This one corresponds to the minimum. And then the one out here, this one corresponds to the maximum. So again, for my set of numbers, then this number is going to be 4, and this number up at the top end is 30. Okay. So a box of whisker plot tells you 5 basic numbers. It tells you the min, the max, and then Q1, Q2, and Q3. Right? Is what that tells you. Right. And then the last part deals with linear regression. So we'll do a little bit here, and then I'm going to show you some stuff on a calculator dealing with linear regression. So in terms of linear regression, so if I have a plot and a scatter plot, so I have some dots like this, right? And you say, well, that looks pretty linear, okay? And it looks like it's increasing in terms of my set of points. And you say, okay, I could probably draw a line going through here, and it goes something like that, right? So what we're going to do in terms of being able to come up with the equation of that line and how good is that correlation, right? So we could have a few things happening here then in terms of this. We're going to have something like this, which is in terms of a positive correlation. Right? As x gets larger, the y gets larger. Right? We could have a plot that looks like this. And so we have now in terms of a negative correlation. Okay. And again, it looks like a strong correlation, but this time as x gets larger, the y value gets smaller, right? Okay. So we could have that. And then, of course, we could have things that are in between where there really is not much of a correlation between one and the other. Right? And so for that, then, let's go and I'm going to pull up a calculator and sort of go through how I would figure this out on a calculator. So let me pull up one of mine here. Right? So we're going to pull up this calculator and see how this works. Right? And we're going to figure out a correlation here. Right? And there we go. All right. And got it up. All right. So to do that, what we're going to do on our calculators, we're going to put in some x and y values. So I'm going to go here on stat. So this works on if you have a graphing calculator. And so go to stat, and we're going to edit our list. And let me get rid of these numbers I had in here from a previous thing. Let's get these out of there. And let's go here. And we'll get these out of there. All right. So now we're going to put in some numbers for our values. So the first number, L1, is going to be my x numbers. So let's start putting in some numbers. Enter 2, 4, 6, 8, 10, 12, and 14. So we got some X numbers in. Now we're going to put in some Y values in. All right. And so now let's go here. Let's go 5. Let's go 10. Let's do 13. Let's do 18. Let's do 21. 25. And 30. Right? So we got our numbers in. Right? Right. So now we want to let's look at a plot of this. So let me first make sure I don't have anything kicking around in here. So let me get this out of here. All right. And I want to look at my graph. And so I'm going to go, let's see, and I got to make sure my stat plot is on. And it is, okay. So let's look at a graph. And let's do zoom. And we're going to do number 9, which is zoom stat. And there we go. There's my plot. And let's see. Oh, that does look pretty linear in terms of that. Right? So now let's look in terms of getting my equation of that line. All right. And so what we're going to do is now go back to our stat. We now go over to calc. And we want linear regression. So ax plus b. So we'll hit enter. And then my x numbers are in L1. My y numbers are in L2, which is what we want. So that's good, that's good, that's good. Store regression equation. What that does, it will save your equation. And let's say we want to do that. The way we do that is we go vars. And then we want y vars and function. Hit enter. I'm going to put that in y1, so that's a good spot for it. And then we go calculate. And it gives me my value of my, so basically the A number here represents my slope, and the B number here represents my y-intercept, okay? Now the other thing which I don't have on here at the moment is we can also figure out how good is this correlation. So we can get what is called the R value. And so let's get that number to show up here. The way I do that on this calculator is I'm going to go second and catalog, and we want to go down, and why is that line there? All right, and we want to turn on, go through the whole list. Here's it, come on. Maybe not. Where is it? Okay. All right, come. Where is it on this one? No. Maybe not. I can't find it. Oh, come on. Where is it? All right. Oh, come on. Where is it? Correlation coefficient. Where's diagnostic? I think I went by it. Actually. Right. Remember what they call it on here? Come on. There it is. Diagnostic on. Okay. Remember what it was called. Diagnostic. All right. On and on. It's done. All right. So now we have that turned on. So now let's go back here. Stat. Let's go back to our calc. Back down to linear regression. Enter. and enter. Again, let's store our equation, and we're going to put that in y bars. Function is good. Y1 is good. And then calculate, right? So now I get my numbers. So the R value. Basically, the closer your R value is to 1, the better the correlation is. So this is basically 1, 0.998. And after all, you looked at my line, and let's go back to my graph. Okay? So now you notice I get my scatter plot, but this line is that line from our equation. And that line almost goes right through every single point that I had, right? So the closer the R value is to 1, the better it is. And if it's a positive correlation, the R will be close to a positive 1. If it's a negative correlation, the R will be close to a negative 1, all right? So in terms of that value, right? So we have in terms of a correlation here and how this works, right? And again, this you want to do on a calculator to have this do this. You could do this by hand, but the calculation by hand is a lot of tedious work. That's what so a graphing calculator is a good way of doing this, right? Right. And so let's go back to our notebook here. And so we have in terms of linear regression and how that works. And with that, that will end this video.